Right. So, a couple of students have asked for the discussion of question number 4, 7, etc. Okay. But I will start with the discussion of question number 1 itself. So, question 1 says a vector is given like this. And we have to find the angle it makes with respect to the positive x-axis. We have to find theta with respect to positive x-axis. Right. Hitanshu, to answer your question, I have sent worksheet number 4 in the group on 24th. And those of you might, I mean, if you had trouble downloading it from the group or the website, then you should have contacted me before, okay? Because I clearly mentioned earlier that I've sent it. It is there on the website as well as on the group. Okay, so please get hold of it. If you have difficulty finding it, then contact me separately. I'll send it to you by WhatsApp. Okay, so let's understand how to solve this question. So this is our xy plane. You can see that in this vector A will have a negative x component and a positive y component. So it is something like this. This is our vector A, where this negative x component is minus 10 root 3 and this positive y component is 10. So you can see this is the angle theta that we are talking about. And if we take this angle as alpha or something, you can say theta is equal to 180 minus alpha, such that tan theta is ay by ax. So that is minus 1 by root 3. Okay. So therefore you can see that alpha must be equal to 30 degrees. So theta is equal to 150 degrees. That is what is showing you that tan theta is minus tan alpha is minus 1 by root 3. Okay. So the angle theta becomes 150 degrees. Okay, so hope this is clear, people. Okay. So that's the first question. Second question is pretty straightforward. Just apply the formula of triangle law. So you will get it from that. Oh, wait a minute. I'll just minimize this so that you can go through this carefully. Okay, if the answer key is given 120 degrees, Rishi, then just make a change. It should be 120. Okay. Let me just check once. Yeah, the answer is wrongly given as A. The correct answer should be option C. Okay, just make a correction in this. The answer key should be option C, not option E. Okay, so let's come to the next few questions now. So question number 2 is very straightforward. I'll just tell you what to do in it. In question 2, you just use the triangle law statement. And you will get the answer. In question 3, let's discuss about this. In question 3, it says that magnitude of A plus B is equal to magnitude of A minus B. Then which of the options can be said to be true from this? Okay, so which of these options is implied? So first, what you have to do is you have to solve for this condition so that you understand what is the relationship between two vectors if this is happening. So the relationship between two such vectors for which magnitude of A plus B is equal to magnitude of A minus B is that this should be correct. Root of A square plus B square plus 2AB cos theta should be, now again by statement of triangle law, for A minus B minus 2AB cos theta. Now square both the sides, so we'll get this. Now solve this algebraically. So you will get 4AB cos theta is equal to 0, which can only mean one thing, that cos theta is 0. Obviously A or B is not 0. Magnitude of A is not 0. Magnitude of B is not 0. We are 0. So only cos theta can be 0 here, which means that theta is equal to 90 degrees, which means that A and B are perpendicular. So A is perpendicular to B. That is the condition which will give you this statement. So this statement implies this, or that statement implies this. If we say mod A plus B is equal to mod A minus B, it implies that they must be perpendicular vectors. Or the moment we talk about perpendicular vectors, it implies that the sum and the difference are the same magnitude. So just make a quick note of this, then we move on to question number 4. No, Iitians, to answer the question, tan 60 is root 3, not 1 by root 3. Tan 30 is 1 by root 3. Yeah, second question, Rishi just used the statement of triangle law. So to take two vectors of equal magnitude, Rishi, and yeah. So there are 5 units each, and the differences of magnitude. So use this formula. Rishi, just pay attention on the board once. I'll show you. So in the second one, you use this formula only. That mod A minus B is this, but in this substitute A and B both as 5, and the value of mod A minus B is 5 root 3. Then you get the value of cos theta from that. Okay. Substitute A and B as 5 each, okay, and mod of A minus B as 5 root 3, and solve just the way we have solved this by opening, squaring both sides and all that. but there you will get the value of cos theta numerically. From that you will come to know theta. Okay, try it out. If you can't work it out yourself, then I'll explain later. Okay, let's come to question 4. So 4 is a question like this now, that it says that the sum of 3 vectors is 0. And something is given about A and B. They are of magnitude 20 and 15. Now something is asked about the vector C. Like it may be some of these options, it may not be. Can it be this value? Can it not be this value? So it says, okay, out of the 4 values given, which of the values can be the value of C? So what you have to understand here is the above statement also means that E plus B plus C is equal to 0. Also implies that C is equal to minus of A plus B. Which also means that the magnitude of C, if you take mod on both sides, the minus sign gets cancelled out. So mod of C is equal to mod of minus of A plus B. So that is the same thing as mod of E plus B. So that means the magnitude of C is equal to mod of A plus B, which is equal to root of A square plus B square, that formula. Okay. Now you can see that mod of A plus B का maximum value कब होता है? It is maximum when theta is equal to 0 or cos theta is equal to 1, and in that case it becomes A plus B, or it becomes in this case 35. And on the other hand, minimum कब होता है? Minimum is when theta is equal to 180 degrees. So cos theta is equal to minus 1. So it becomes difference. So it becomes, in this case, 5. Okay. So this is the minimum value, 5. This is the maximum value, 35. So this is showing us that magnitude of A plus B for any value of theta cannot be greater than 35 and cannot be less than 5, because it is given to us that A is 20 and B is 50. So now we can say the same about C. Therefore, magnitude of C. So based on this, now you can see now we can see which of the options are correct, which of the options are wrong. We can see option A says that can it be 4? You can see it cannot be 4. Option B says that can it be 16? Yes, it can be, because 16 falls within that range between 5 and 35. Can it be 40? The answer is no, because it's greater than 35. Similarly, D option, can it be 50? The answer is no. That's greater than 35. Okay, people, so hope this is clear. Yeah, The minimum and maximum part is like this. Let's see. You have this, that magnitude of a plus b is root of a square plus b square plus 2ab cos theta. So इसका maximum कब होगा? This will be maximum when cos theta is maximum. And that is 1. Okay. So for that, theta should be 0. Okay. So for example, if you have two vectors of magnitude 20 and 15, okay. Now when will the resultant sum be maximum? When the angle between them is 0. So they look like this. If this is the case, then the sum of a plus b will become this vector here. So this will have a magnitude of 35 if this is 20 and this is 15. But this is when theta is 0. For any other theta less than, theta greater than 0, you will see that the magnitude will become less. So for example, if this is the case, we have theta not equal to 0. This is 20, this is 15. Now you can see that the resultant is becoming less. So the magnitude of the resultant is less than 35 in this case. Okay. And similarly, when will it be minimum? Okay. So this is the maximum case when theta is 0. Now similarly, when will it be minimum? So cos theta's minimum possible value is -1. That happens when theta is equal to 180 degrees. In that case, your mod of a plus b's minimum value becomes root of a square plus b square minus 2ab. So that is just the magnitude of the difference of a and b. So this case, visually, if you want to understand it, this is when it happens. A is a vector like this. B is a vector which is opposite like this. Then the resultant of these two vectors will become a vector like this. So this is the case when theta is equal to 180 degrees. The magnitude of a plus b actually becomes the difference of their magnitudes. Okay. So this is the minimum magnitude. So for example, if a is 20 and b is 15, then magnitude of a plus b will become 5 for theta equal to 180. Whereas when it is 90, you've seen it as root of a square plus b square. Okay. So that's a different case. So combining these two statements, the minimum value इतना है और maximum value इतना है. So you can see combining the two, can never exceed e plus b and can never become less than the difference of e and b. Okay. But this occurs, this maximum value occurs for theta equal to 0 degrees. of parallel vectors, and this minimum value occurs for theta equal to 180 degrees. That is, they are what we call anti-parallel vectors or opposite. So this is an important factual aspect about vector algebra. Okay, so I'll just lead you through this part. Okay, so hope this is clear, people. Okay, so this is a general statement that we can make about any vector. All right, let's move on to the next few questions now. So question 5, that is also based on this kind of logic, but there the angle is given as obtuse. So it's given that magnitude of the vector P is 12. The magnitude of the vector Q is 16 and theta is obtuse. That means theta is definitely greater than 90, less than equal to 180 degrees. So that basically means what? That cos theta is less than 0 but greater than equal to minus 1. So for example, so basically cos theta is a negative value. That's the important thing over here. So therefore, what we can say about magnitude of P plus Q, the resultant, it is such that now this cos theta now is between 0 and 1. Sorry, 0 and minus 1. Okay, it can't have positive values. Okay. So what is this resultant's maximum value? Okay. So it's not even equal to 0. It's less than 0. So to understand here, 90 nahi ho sakta hai. It's obtuse, no? It has to be greater than 90. Okay. So since theta is greater than 90, okay, therefore cos theta is less than 0. So that means magnitude of R is less than root of P square plus Q square. Because this quantity here is negative. You can see this is now a negative quantity. So that means from this you are subtracting something. So the magnitude of R has to be less than this. Okay? Whereas on the other hand, cos theta's minimum value is minus 1. Okay? So that means R is greater than equal to P minus Q's magnitude. Because on the other hand, okay, so this is like the maximum value in this case. This is like the minimum value in this case. But just remember, in the maximum value, you don't include the 0 term because it has to be greater than 90. So from these you can see that for theta equal to 90, okay, R would have been root of P square plus Q square, which in this case would have been 20 because they are 12 and 16. Okay. So for theta greater than 90, magnitude of the resultant has to be less than 12. That's statement 1. Okay. And on the other hand, for theta equal to 180 degrees, magnitude of R will become difference of P and Q, which is 4. Okay. So this is statement 2. So in general, R has to be greater than equal to 4 for any theta. So this is my second statement. So combine the two now and you'll understand that your resultant sum of P and Q has this kind of thing. It cannot be 20, it has to be less than 20, but it can be up to 4, not less than 4. So this is the range of values possible now. Why this is the case now? Because theta is obtuse. If nothing was said about theta, then it would have a larger range. It would be from P minus Q to P plus Q. But here it's said that it's an obtuse theta, so it's becoming limited by this. Okay. So just go through this question, people. Alright, so basically it's this thing. The moment you see this, cos theta is between 0 and -1. You can see that in this case, mod of p plus q is less than equal to root, sorry, less than, not equal to, because it cannot be equal to 0. It's less than 0, so it's less than root of p square plus q square. And on the other hand, greater than equal to -1, so that means it's greater than equal to the difference. So that's how we are finally getting this. How did we get theta more than equal to 4? No, not theta, but magnitude of r. So see, ये वाला ना, p is given as, p's magnitude is given as 12 and q's magnitude is given as 16. So this thing becomes 4 and this thing becomes 20. That's how we got between 4. So when is the resultant the minimum possible value? That is when cos theta is the minimum, which is -1. So when cos theta is -1, you can see this is root of p square plus q square minus 2pq. So that is the term. That is the time it will become 4. Whereas on the other hand, if cos theta was 0, because theta was 90, then it would have been root of p square plus q square, which is 20. But here it cannot even be 90. It is greater than 90. So your cos theta is never equal to 0. It is less than 0, whereas it's always greater than equal to -1. So that's why this term is less than root of p square plus q square, but greater than equal to the difference. Okay, Hari, hope this is clear. All right, so this was question number 5, I think. Was it? Yeah, question number 5. Now let's move on to question number 6. In 6, I think there is an error in the answer. Let me check. The easiest way of doing question 6 is that you write the two vectors in component form. In question 6, we are given vectors p and q like this. P is a vector of magnitude 10 and this angle 30 degrees. Okay. So in component form, P will become how much? It will become 10 cos 30 I cap plus 10 sin 30 J cap. So it will become 5 root 3 I cap plus 5 J cap. Okay. Now similarly, the vector Q is given to us, which looks like this now. Looks very symmetrical. Symmetrical in the sense that it has the same magnitude as P, 10 units. Okay. And this angle is 30 degrees. Okay. So what you do is you write Q also. Try this out. Okay. And then you find P minus Q. Use vector algebra to find how much P minus Q. So just try this out, all of you. Correct. Prashant, your final answer is correct. So I think there will be a correction in the answer in this, because the answer at the back is given as 20 J cap. It should be 10 J cap. Yes, Rahil, correct. Good. Yeah, Shomaru, correct. Shikhar, correct. Yeah, Shikhar, I've got your message. Okay. So the vector Q here, when you work it out, you'll see will come out to be 5√3 I cap minus 5J. Because for the vector Q, actually, for Q, the angle theta is minus 30 degrees or 330 degrees. It's quadrant 4. Okay. So for it, cos theta is plus cos 30, which is root 3 by 2. But sin theta becomes minus sin 30 or minus half. This is quadrant 4. Cos is positive, sin is negative. That is. So that's why sin is negative, so y component is negative. Now you do p minus q, so you can see you get this minus this, so that is 10 j cap, and the x component cancels out. So this should have been the correct answer. It's my mistake. There's a misprint in this thing, and it's given as 20 j cap. Okay, so just make a correction. Option C should be this. It should be 10 j cap. Okay, people. So hope this is completely clear now. Now let's move on to next question. So that was sixth question. Okay. I think seventh is fairly easy. Yeah, seventh you can work out yourself. Anybody has doubt in seventh question? Please send me a text message if you have a doubt in the seventh question. So that is the thing, Ritika. If you solve by triangle law method, you will get only the magnitude. Na? You will not get the direction in terms of I cap, J cap. You understanding my point, Ritika? The thing is, the answers are given in I cap, J cap notation. Na? So therefore, we have to solve it in component method. If only the magnitude of P plus Q or P minus Q was asked, then we could have taken both the options. Triangle law से भी निकाल सकते थे या component method से P minus Q would have come 10 J cap. Then we would have taken mod of this, so it would have just come 10. But since it is asking, the answer is asking in I cap J cap notation, so we don't have the option. We have to do it by the component method. Hope the point is clear. Okay. So triangle law will give us the magnitude as 10 units, but it will not give us an I cap J cap notation. That is the thing. That's why. Okay. Okay. So let's do question number 7. People have asked it as a doubt. So question 7 we'll see by two different methods. So it is saying that P and Q are vectors at an angle of 150 with respect to each other. So theta is equal to 150 degrees. Okay. And the resultant, that is P plus Q, is such that the resultant is perpendicular to P. Okay, this is the resultant is perpendicular to P. Then the ratio of P is to Q we have to find out. P is to Q. Okay. So one is we can use the statement of triangle law. So triangle law का statement. So method 1 we can do like this. By triangle law, you see that no need to draw the triangle. Actually, I'm just drawing for your reference. So in this case, theta is 150 between them. So it's something like this. So if this is a vector P, this must be the vector Q. And this angle between them is 150 degrees. Okay. And then the resultant of these two is this one, where it is given that the resultant is making an angle of 90 degrees. So our alpha is equal to 90 degrees. Okay. If you draw the triangle, you can directly use trigonometry. Okay. So you can see that this angle here will become 30 degrees. Okay. So cos 30 will become base upon hypotenuse. So this is P. The magnitude of the base is nothing but this, and this is Q. So that is nothing but P by Q. So this is the easiest way of doing the question. So P is to Q will become cos 30, which is root 3. Or we can go by formula. Okay. So formula में क्या होता है? Formula based method में tan alpha should be Q sin theta upon P plus Q. Okay. So tan 90 should be equal to Q sin 150 upon P plus Q cos 1. Okay. Now this is where you have to understand the mathematics carefully. इसको हम आगे कैसे solve करेंगे? So tan 90 is undefined. So that means this quantity should be undefined. Okay. Now sin 150 is half and cos 150 is minus root 3 by 2. So you're using this formula, of course, that sin 150 is sin 30, so that is half, whereas cos 150 is minus cos 30. that is minus of root 3 by 2. Okay, so that's fine. So अभी देखो क्या हो रहा है, this quantity, this left hand side is undefined. I mean this right hand side is undefined. So that means if I say some fraction, some numerator divided by some denominator is undefined, it means that the denominator must be 0. Okay, this is the thing I have to understand. So यहाँ पे क्या हो रहा है, this q root 3 by 2 must be 0. So this will now give you the same relation. So this is the geometrical way of doing it. Whichever you find convenient, you can do, because it's a nine. I mean, because the question is mentioning that the resultant is perpendicular, so you can just do it by drawing the triangle. You don't even need to apply the statement of triangle law. Drawing the triangle is also as good as applying triangle law. We are using the vector triangle, or you can use the statement of you, or you can avoid drawing the triangle and instead just use the formula in the statement. But in that case, you'll have to solve this technical thing that your alpha is 90 means tan alpha is undefined. So your b sin theta upon a plus b cos theta. In this case, it's q sin theta upon p plus q sin theta. In that, the denominator must be becoming 0 because it is undefined. Okay, so just note this method down. Then we'll also see how to do this by component method. We'll also understand how to do this by component method. In fact, you can try this yourself by component method. Okay, if you understood this method, try it by the component algebra method. Okay, so let's understand how we do this by component method instead. Actually, at some stage you'll realize that almost every sum can be solved by component method. It's like a default method. उससे तो हो ही जाएगा. But sometimes it is easier to solve by geometry. Sometimes it is easier to solve by component. But if you think of it, what is the most reliable method? It is the component method. So if I assume my x and y axis are like this, and if I assume that my vector, so it's only saying that p and q are at theta equal to 150 degrees, okay? And the resultant is perpendicular to p. So because resultant and p are perpendicular, you can start with this. Like let's take x-axis along the vector p. Okay? If my x-axis is along the vector p, then my vector p must be looking like this in this diagram. And then this is at 150 degrees. So my vector q, let's assume, is something like this. Where this angle is 150. I could have taken from here also 150 in third quadrant, but I'm just okay. So now you can see the resultant of P and Q should become something like this. It should be perpendicular to P. So that means the resultant should be like this. This should be my resultant because that one is perpendicular. So let's just solve for this condition. So my vector P will according to this become Pi cap. Let's write this below. So according to this now, my vector P is some unknown magnitude but along the x-axis. But what about my vector Q? If its magnitude is capital Q, what about its components? Okay, so again use those values. Cos 150 is minus root 3 by 2 and sine 150 is plus half. So this should become minus root 3 by 2 times Q I cap plus Q by 2 times. So therefore the resultant, which is P plus Q, will just become, add these two vectors. So it will be P minus root 3 by 2 Q I cap plus 0 plus Q by 2, so that's Q by 2. Okay. Now we have to apply the condition that the resultant should be along. So the condition for the resultant will be perpendicular to P. That is that the resultant is along the y-axis. So if it is along the y-axis, the resultant should just be some y component j cap. Its x component should be 0. So apply. So the condition for this perpendicularity becomes that its x component is 0. So now see above what is the x component. It is P minus Q root 3 by 2. This should be 0. That's it. That will give you the answer. Okay. So this is another very convenient way of solving a question like this using the component diagram. And gradually you should get more and more used to how you can solve questions by component method. That is typically the more reliable, straightforward method. Because we have assumed P is along the x-axis, and that is why we have assumed that Q is at 150 degrees to the x-axis. See, we can take our xy coordinate frame as we like, no? Okay, so hope this is clear, people. Yeah, Q ऐसे आ रहा है because cos 150 is minus root 3 by 2, and that's all. So Q के components क्या हो जाएंगे? Qx is Q cos 150 and Qy is Q sin 150. Understood, Asumar? Are you adding these two vectors, beta? P plus Q कर रहे हो ना? So P plus Q क्या हो जाएगा? It will be P's x component plus Q's x component into I cap plus P's y component plus Q's y component into j cap. Now just substitute these values. So P's x component is how much? P. Q's x component is how much? Minus Q root 3 by 2. P's y component is how much? 0. Q's y component is P by 2. So now you want this resultant to be perpendicular. So that is the condition that Rx should be 0. The resultant in the diagram you can see is not having an x component. That means अभी इसका जो x component है वो कितना होना चाहिए, 0 होना चाहिए. So what is the x component of the resultant? It is p minus q root 3 by 2. See, this is your resultant vector, no? So its x component is which one? This one. This is the resultant's x component, and this is the resultant's y component. Now the condition for perpendicularity is that the resultant's x component should be 0. Okay, so hope this is clear. Okay, let's move on to 8th question. Pretty straightforward question. I'll just tell you what to do. So use the formula of e plus b and e minus b and apply the condition that mod A is equal to mod B. So in question 8, it is given that magnitude of A is equal to magnitude of B. So let's assume that is x. And given that mod of E plus B upon mod of E minus B is 1 by root. Okay. So from that we have to find theta, the angle between them. Right, it's 1 by root 3. Okay. So just expand this. So root of E square plus B square plus 2ab cos theta upon same thing but with minus ab cos theta is equal to 1 by root. Now square both the sides and substitute mod A and mod B as x. So put E and B both as x each and square both sides. So you will have x square plus x square plus 2x square cos theta upon x square plus x square minus 2x square cos theta is equal to 1 by 3 on squaring the other side. To cancel x square, so you have 2 into 1 plus cos theta in the numerator upon 2 into 1 minus cos theta. So when your 2 gets cancelled out, is equal to 1 by 3. Now solve for cos theta and then from that find theta. Very straightforward question in that sense. Okay, so I'm just minimizing this. You can go through the working. That's question number 8. So finish this fast and let's come to question number 9. Yes, Somarup, the answer is correct. Okay, question 9 is again component algebra. Yeah, Priyank, 120 is the correct answer. You'll see cos theta will be a negative quantity, so it's 120. Cos theta will come minus half. Okay, so 9th question. Again, what? Yeah, Durgesh, 120 is correct. 120 is the correct answer. Because cos theta will come out to be minus half. Okay, so question 9 again, what you do is you convert this into components. Yes, Hitansh correct for question 8. Now come to question 9. So write your two vectors in component form and then apply the condition given in the question. Okay. So vector E has an unknown magnitude, but its angle with the x-axis is 60. And vector B is like this. And the condition is that E plus B is along y-axis. So this is how we will proceed here. First, write A and B in component form. Then find the resultant and then apply this condition here so that resultant's x component should become how much? 0. So just try this out quickly. There is only one way of doing this question, and that is by this component method. Okay, so got this, people? See, vector A in component form will be, yes, correct. A cos 60, which is half, so E by 2 I cap plus A sin 60, that is root 3 A by 2. And B in component form is minus 10 I cap. Okay. So now the resultant in component form becomes what? Seems like that question we did. It's E by 2 minus 10 I cap plus root 3 A by 2. Now we want this condition that resultant is along y-axis. So for that, the resultant's x component should become 0. So E by 2 minus 10 should be 0. So that means the magnitude of E should become 20. So that's one thing. And then what about the resultant itself? So the moment the magnitude of E becomes 20, the resultant becomes just this term. It becomes root 3 by 2 E j cap, or the resultant itself becomes 10 root 3. So now, depending on whatever the question is asking you, yes, I will check options. Yes, you can also do using simple trigo. Okay, that's fine. If you're done using trigo or triangle or whatever, that's also fine. But it's just more convenient to do these type of questions using component method. Okay, now let's come to question number 10. question 10 is saying the sum of three displacements is 0. So let's say those displacements are E, B and C. So A plus B plus C, the net displacement should be 0. So again, this is that type of question, that A is equal to minus of B plus C. That means the magnitude of A should be equal to the magnitude of B plus C. Okay. Or if you think of this like a triangle, it's like this. If this is B and this is C, then in this case A should be like this. So that, so let's say B and this is C. So this vector is A, because the vector which is the resultant sum of B and C would have been this vector here, this vector like this. So A is minus of that. This is the resultant of B plus C. In the diagram you can see A is negative of that result. That's why A plus B plus C is. Okay. So that means the magnitude of A cannot exceed B plus C and cannot be greater than equal to, cannot be less than B minus C. That's the minimum maximum concept. That the resultant sum of two vectors has a maximum possible value of B plus C and a minimum possible value of the difference. Okay. So based on this, let us look at the options. So if you look at option 1 or option A, it says 10, 12, 15. So you can see that if you take these as B, C and A, or whatever order you take it in, okay, but you can see that 15 is less than the sum of 10 and 12, and it is greater than equal to the difference. It's fine. It can be. But for example, if you take this option, 865, then also you can see it's fine. Okay. This is ABC, for example. You can see 8 is less than equal to 6 plus 5, but greater than equal to 6 minus 5. This is also correct. Now, let us see, for example, the option C. The option C is saying 8, 6, 18. Now you can see that 18 is actually greater than 8 plus 6. So if you were to assume that this is the side A and these are the sides B and C, you can see A's magnitude is becoming greater than B plus C. So this is not possible. Okay. So that's why this is the wrong option. And similarly, you will see D is again a right option. Okay, so in very simple terms, you can see here that if I say A plus B plus C is equal to 0, that means A, B, C are sides of a triangle. Now there is a simple principle in triangle that the largest side is less than the sum of the other two. Okay. In this case, we can take less than equal to also, because a triangle can collapse into a straight line. So that is what is going wrong in option C. The largest side is 18. It is becoming greater than the sum of the other two sides. So hope Ananya is clear to you what I'm saying over here. You have to consider the largest of the three sides and then understand that it should not be larger than the sum of the other two. Okay. Yeah, that's why, because it is the incorrect option you have to select. Okay, the question is saying select which option is incorrect. That is why the option C is selected. For example, in this case, if you take 8, 6 and 18, and suppose you take this as E, okay, and you take this as B and C. Now you can see that what is the difference of B and C? The difference of B and C is 8 and 18 and 6 is difference, which is 12. Whereas what is the value of E? It is 8. So again, it is violating the triangle principle, that this is becoming lesser than the difference of this and this. So that's not possible. So that is how you rule out if you take it like that. Okay. It's not that you have to consider the largest side as A. You can consider any of the sides as A, B, and C. But it is just the principle of the triangle, okay, that the largest side should be less than the sum of the other two sides. Like I said, you can consider any three sides. Now you can see here, A should be greater than equal to, I've done the opposite now, I've just taken the middle side as A. So it should be greater than equal to B minus C, but less than equal to B plus C. So according to this, substitute the values of B and C here. So it should be less than equal to 24, so that's fine. But it should be greater than equal to 12. Because what is the value A given? It's given as 8, so that you can see it's not possible. Okay, so that's question number 10. Now let's move on to the more than one option correct type of questions. So question 11. In question 11, just use triangle law. Mod A is given to you as mod B is given to you as 10 and theta is equal to 120 degrees. So use triangle law for mod A plus B, mod A minus B, and so on. So this you will get fairly easily. Okay, let's come to question 12. Now it is saying that magnitude of A is 12, magnitude of B is 16. Okay. But the magnitude of their difference is coming greater than 20. Mod of A minus B is coming greater than 20. Okay. Then which of the options are correct? Okay, so let's understand what this is saying. So root of A square plus B square minus 2AB cos theta is coming greater than 20. So if you square both the sides, this, okay. Now substitute A as 12 and B as 16. So you get so you will basically get 12 square plus 16 square is equal to 400. Yes. So you can cancel the 400 with this. So 400 minus something is greater than 400. That basically means that this quantity is a negative quantity. This thing is negative. Implies that cos theta is a negative quantity. That means theta is obtuse. So based on that, now you can check. Yeah, Prashant, to answer your question, 11th, the answers are A and B. You can check that out by component method, Prashant. Or you can understand by parallelogram law. See, magnitude of A and magnitude of B are same. So when you draw the vector parallelogram, realize that it becomes a rhombus. This side is equal to this side. They are both of 10 each or whatever. And this angle is 120. Now the property of the rhombus is that the diagonals are perpendicular to each other. So A plus B and A minus B will become perpendicular. You can use that as a property of the rhombus. For question 11. Or you can use component algebra. Okay. No, option C will not be correct. Option C is only correct when theta is 90 degrees and theta is given as 120 degrees. And option D is correct when theta is an acute angle, whereas theta here is an obtuse angle. So C and D are not correct. And in any case, C and D cannot be simultaneously correct. Okay. C के लिए क्या होता है? Theta should be 90 degrees, but here that is not the case. Or D के लिए क्या होता है? Theta should be less than 90, but that is not the case here. Theta is 120 in the case of 11. Okay, so let's come to 13th question now. So in 13th question, what you should do is, to solve the question, you should consider a hexagon like this. So this is the rough diagram of a hexagon. The corner points are like this. And you should consider this as your x-axis. And this as your y-axis. So in that case, you can see that since they are of side length 10 each, you can write the vector AB as just 10 I cap, but the vector BC will be such that this angle is 60 degrees. Okay. So it will become 5 I cap plus 5 root 3 j cap. And then for the vector CD, you see this angle will become 120 degrees. So CD will become minus 5 I cap plus 5 root 3 j cap. And finally for the vector DE, the side length is 20. Okay, so just change that, that's fine. So this will become 20 . So this will become 10 I cap plus 10 root 3 j cap. This will become 10 I cap, rather minus 10 I cap plus 10 root 3 j cap, and DE will become minus 20. Now use component element. Okay. So basically how I'm getting this is by using the property of a hexagon. The important thing is this property, which I'm showing now. A regular hexagon has this property that, not drawn it very accurately, but it's a combination of 6 equilateral triangles. They're all equilateral triangles. So these side lengths are L. Then each of these are also L. Okay. So then what happens is, in terms of angles, this is 60 degrees, this is 60 degrees. This is 60. Now that is why, now in this triangle these are also 60. So this angle becomes 60. And this triangle, these are all 60. So you can see this angle becomes 120. So you make use of this property and then you orient it correctly with respect to your XY axis system, so that you can resolve and write it nicely like this. No, Rushan, it should be 10 only because the side length we are taking as 20. So AB is equal to BC equal to CD like this, equal to 20. But for example, BC will become 20 cos 60 I cap plus 20 sin 60 j. Similarly, CD will become 20 cos 120 I cap plus 20 sin 120 j. Yeah, you can consider the point A as your origin. It doesn't matter. You can take any point as your origin. Important thing is EB is along the x-axis. Yes, Somaru, the side length is 20. They're all 20. Okay, so write them in component form like this, and on the basis of that, you'll be able to get this. Shikhar, regular hexagon. We are using the properties of a regular hexagon. The diagonals of the regular hexagon, if you join them, it breaks it into 6 equilateral triangles. That's why these angles are all 60. Now, if this angle here is 60, okay, this angle here in this other triangle is also 60. That's how this exterior angle here is becoming 60. Again, this angle here is 60. That's why this angle is becoming 120. So now you're making use of that property in the vector diagram, where this is the vector EB, the displacement vector from A to B, the corner A to B. Similarly, the vector BC is the displacement vector from B to C. Similarly, CD is from C to D. That's how you're expressing them in component form like this. I've written for you here. That's the thing, no, but it's coming from geometry. See, this angle is 60 here, so that's why this angle is 120. So that's why when I express this side CD as a vector, it is making how much angle with respect to the x-axis? 120 degrees. Okay. Because this interior angle is 60, no? So this angle is the x-axis का direction ये है ना, this is the positive x-axis. So that's why when we consider CD's angle, it will be this one. Na? This 60 is the angle with the negative x-axis. This is the angle with the positive x-axis. That's one. So you just separate out these vectors. Na? BC कैसा vector है? BC ऐसा vector. So it's making an acute angle with the x-axis. But CD कैसा vector है? It's like this. So it's making an obtuse angle with it. Understood? That's one. Okay, good. So still you have work to do in this question, but I'm just saying how to work it out. Once you've written these in component forms, just substitute these in the options and you'll get the answer. Okay, let's come to 14th question. Now 14th question is saying P is a displacement of 10 meters towards east, Q is like this and R is like this. Then which of the following options is correct? Okay, so let's first draw the vectors and convert them to component form. That's all you have to do in question 14. So let's assume that we have drawn our XY system such that x-axis is pointing towards east, y-axis is pointing towards north, west and south. So in this diagram, our vector P will be where? It will be pointing towards east and 10 meters. So P can be written as 10 I. Now you notice what is said about the vector Q. It is of magnitude 20 and it is at 60 degrees north of west. So the vector Q will be lying somewhere here, 60 degrees north of west. Will be like this. This angle is 60. Okay. So therefore, this angle with the x-axis is how much? It's 20, 120. This angle. So therefore, when you write out the vector Q in component form, you will get it as minus 10 I cap plus 10 root 3 j cap. Just write it in proper component form. And similarly, you will see your vector R will be like this. Now R will be 30 in magnitude, but this angle is 60. So the angle with the x-axis is actually 180 plus 60. So R has both components negative. So R will become minus 15 I cap minus 15 root 3. So once you've written them in component form, now it's again easy. Substitute in the options and see which ones are correct. Okay. So the main thing is the resolution of the vectors according to the directions given. So make sure you're clear with the diagram. First of all, how I've drawn the vectors according to the angles given in the question, and then how I've resolved it in component form by taking xy axis along the east and north as shown. Ready? Okay, so hope this is clear to you people. Okay, so now 15th question. Yeah, okay, good. Alright, so let's quickly go through the 15th question. So you have a vector given to you and you have to select another vector which is perpendicular to the first one, right? And of a certain magnitude. So in 15th question, you have this situation that you have one vector given to you as I cap plus root 3 j cap. Another vector given to you in unknown form, x I cap plus y j cap. It is given to you that they are perpendicular to each other, okay, and B's magnitude is 4. So E is perpendicular to B and magnitude of B is 4. So the best way is to try and understand this from geometry or from the diagram. So if you draw the vector E over here, yes, the magnitude of A is 2. And what about the direction? It is such that this angle is 60 degrees. You can see this is magnitude is 2, but this angle is 60 degrees. So what about B? One option is that B could be like this. So magnitude 4. Another option could be that B is like this. It could also be like this. Another option. It could be some vector B prime whose magnitude is 4, where this angle is 9. But let us work out the option B first now. So for the vector B, you can see that magnitude of B is 4 and theta with the x-axis is how much? 90 plus 60 or 150. You just write in component form. Okay? So the x component of B, which is B cos theta, will become 2 root 3, sorry, minus 2 root 3, and the y component, which is B sin theta, will become 2. So the vector B is becoming minus 2 root 3 I cap plus 2 G. Now if you just observe in the above diagram, you will see that the other possible option, which is B prime, is nothing but minus of B. It's equal and opposite. It's a vector of equal magnitude but opposite in direction. So B prime will just become like this. इसमें minus sign multiply कर दो. So 2 root 3 I cap minus 2 G cap. So these are the two possible answers. So that is why there are two sets of values possible. Either x and y are 2 root 3 and minus 2, or x and y are minus 2 root 3 and plus 2. Okay, hope this is clear, people. How did we get angle of A 60 degrees? We got it by the formula that tan theta is AY by AX. So root 3 by 1. We didn't consider it is according to what is given, but it's formula based. From the components of a vector, how do you calculate the angle? Tan theta is y component divided by x component. So A का x component कितना है 1 है, y component कितना है root 3 है. So that's how. Okay. All right. So that completes this worksheet. Okay. So just the questions which I've given you hints, just try to finish them off yourself. And if you still don't get the final answer, just send me a message. I'll help you out. Okay. Now, just a couple of things I want to discuss before we complete the session. But just a moment, I'll have to refresh the screen. Just give me a second, please. So now the next thing we'll see is components in 3 dimensions. For that we consider a 3-dimensional, what we call rectangular or Cartesian coordinate frame which consists of mutually perpendicular x, y and z axis. So just visualize this diagram now. Suppose these are 3 mutually perpendicular axes. Like, this is, so the way to visualize this now is, this is one corner of your room. Just look at the room in which you're sitting. So this is one corner which you can see to your, in front of you to your left, the corner that you can see, that is the origin, suppose. Now the edge of the floor and the wall, that one is the x-axis, and the wall in front of you, that one is the xy plane. This one. So the common edge of the 2 walls, which is to your left corner, that one is the y-axis. The edge between the floor and the front wall, that is your x-axis, and the edge between your side wall, the wall which is to your left-hand side, and the floor, that is your. So you can see that these are 3 mutually perpendicular planes. This is like the floor in which you are sitting. This is one of the walls in front of you, and this is the other wall which is to the side of you. That's how you realize how the XYZ axis works. They are all mutually perpendicular. So this is one way to visualize the mutually perpendicular XYZ axis. Okay. Another way to visualize the same is that you just think of a cuboid like this. Now in this cuboid, what you do is you make one of the edges your x-axis, one of the edges your y-axis, and the third edge. So you can see they are mutually perpendicular edges. So these two are perpendicular. These two are also perpendicular, and on the floor these two are perpendicular. So this is our 3-dimensional coordinate system where x, y, and z axes are mutually perpendicular. Okay. So just make a note of this first, then we'll see how to write a vector in the 3-dimensional notation. Okay, so now once you understood the 3-dimensional coordinate system, now we look at unit vectors, the standard unit vectors. The next thing here is or what we also call the base unit vectors. So I cap and j cap are the same as they were before, but now we include a third one which is called k cap. This is a unit vector which is along the positive z axis. Right. It's along the positive z axis. So any vector is now expressed in this form: ex I cap plus ey j cap plus ez k cap. This is a vector in 3D component form. Where ex, ey and ez are the components of vector E along x, y and z respectively. Okay, so it's very simple. There's nothing difficult about this. It is just an extension of the two-dimensional concept. So for example, if I have the vector E, which is I cap plus 2j cap plus 3k cap, and I have a vector B which is I cap minus j cap plus k cap. And I say find out E plus B. So you just do it in the same way, like we've done for 2D. So it will become E is x component plus B is x component, sum of y components. But now along with that, there's a sum of the z components. So from above you can see sum of x components will become 2, sum of y components will become 2 minus 1, so that will become 1, and sum of z components will become 3 plus 1, so 4. So that is now becoming your E plus B. Similarly, if we were subtracting A and B, we would subtract the components. Okay. So there is nothing that difficult about converting two-dimensional to three-dimensional. It's just adding one more component. Okay. So just note this down first. So first of all, note down the concept of what is k cap. So it is a unit vector along the z axis. Like I've drawn, right? Exactly the way I've drawn, that's the same way you have to do. Yeah, 3D vectors you cannot draw. That is why we do component algebra. You can only draw on a two-dimensional plane. So you cannot compare two three-dimensional vectors by drawing them geometrically. That's why the component algebra becomes necessary. Okay. So just note down this example. Okay. Now next, let us understand the interpretation of this. Yeah, I'm coming to that. In the interpretation, we'll understand the magnitude. So the interpretation is like this, that so as usual, if you're taking this as our origin, this is our x-axis, this is our y-axis, this is our z-axis. Now imagine that this is a cube, or this is a cuboid with sides of length ex, ey, and ez. So this length here is ex, this height here is ey, and this width here is ez. So then in this diagram, what would be the vector ex I cap? The vector ex I cap would be this one. This vector along the x-axis from the origin. This would be our ex I cap. Similarly, what would be the vector ey j cap? That would be this one. And what would be a vector ez k cap? That would be this. So each of the edges from the origin with a proper direction towards the vertex on each of the axis becomes each of the individual vectors ex I cap, ey j cap, and ez k cap. So what will their sum become now? Their sum will become this diagram. The sum of these three vectors, which is ax I cap plus ay j cap plus az k cap, will become this, which we call the body diagonal. This one, this will become vector. So that is the interpretation. So the vector E is basically what we call the body diagonal of a cuboid with sides ex, ey, ez. Okay. So if one vertex or one corner is O, then the sides can be expressed as ex I cap, ey j cap, and ez k cap. So the vector E, which is the body diagonal, can be expressed as ex I cap plus ey j cap plus ez. So this is the interpretation. So you can see here ex I cap plus ey j cap plus ez k cap will bring you to this corner. And therefore, we can also say that the magnitude of the vector E will become square root of ax square plus ey square plus ez square. Because that is the formula of the length of body diagonal. Formula for the length of body diagonal. Okay. So this is the interpretation of what we mean by a three-dimensional vector. We have to imagine it. Okay, you have to imagine you are sitting in a room in which each of the edges, the two edges on the floor, are ex and ey, or ax and ez, and the edge with the wall is ay. Now the body diagonal, which is from the corner in front of you to your bottom left to the corner behind you, which is to your behind upper right side, that body diagonal becomes your vector. And that body diagonal's length is given by root of L square plus B square plus H square, length, width and height. So that over here becomes AX square plus AY square plus AZ square. Alright. So this is the interpretation of three-dimensional vectors. So this is where we'll stop today, guys. And as you can see, three-dimensional vectors is just an extension of 2D. There is nothing very difficult. Addition and subtraction happens by same principles, and the calculation of magnitude also happens by same principles. Only thing is we cannot solve 3D vectors by geometrical method. We have to solve them by component method, because we cannot draw on three-dimensional space. We can only draw on two-dimensional. So all the algebra that we do with 3D vectors is only using IJK form or the component form. We don't have the equivalent of geometrical laws for doing addition, subtraction, etc. of three-dimensional vectors. Okay, that's another reason why component algebra is more important, because in general you can always have three-dimensional vectors, and then to relate them algebraically you have to use the components method. Alright, is this clear, people? So that's it for today, and you will get another worksheet, and also for worksheet 4, very important worksheet. So any questions remaining, make sure you discuss with me. Based on today's lecture's hints, you try out any questions that you could not solve, and any questions you are not getting the final answer, or you're not able to understand how to solve using the methods I've given. Make sure you clear them with me, because next session we will be starting dot products. So that will get into products of vectors. So before we get into products of vectors, make sure that at least up to worksheet 4 everything is clear. Worksheet 5 will be based on 3D vectors like I've shown today, but it will be more like a revision thing, because all the principles are same as worksheet 4. Worksheet 5 on 6 onwards, you will get into products and new things. So that is why I'm saying that this week, make sure before weekend you are clear with everything related with worksheet 4 at least. Okay, that's it, guys. Thanks.